Okay, so I'm all set up. Yeah, so I got a selection of aluminum. I have some that's 1/8 inch wall, some that's a little thinner. I don't have any 90,000s, but I have some like 16 gauge, and then I have some 3/16 aluminum as well. So hopefully that gives you an idea of a couple different various thicknesses there. All right, so I guess I'll start off with discussing some of the things that are different here with the laser welding process than TIG and MIG. So the laser is going to have a lot of benefits in the sense that the energy is much more focused. So it'd be called a higher energy density, and the higher energy density of the laser weld is going to accomplish a couple things. Firstly, it's going to penetrate very deeply into the material without any issues. You also have a lot of control when you're welding thinner materials with the laser because the heat is not spreading out through the material as fast, so it's not as likely to kind of like open up a gap if where you might see that being a very common issue with other types of typical welding processes. The welding happens much quicker because we are getting the energy into the weld joint much more efficiently. So we don't have to wait on the part to heat up for that and that weld pool to grow into the metal. The laser just gets right to the point and does its work very, very fast. So you introduce less overall heat into your part. So you're going to have a stronger weld joint at the end. Um, you're not affecting the structure of the metal nearly as much. And it's really easy to use. The laser welding process, a lot of times we'll have people give it a try for their very first time, and they can lay some good beads down within a couple of tries. It's not like TIG where you need years and years of experience to be really good with it. This one maybe you'd be able to feel very comfortable using it within a day, and within a week or two you'll be real good at using it. Um, so yeah, any questions so far about the process? Anything that you were wondering before we started the demonstration or anything like that?
No, I've done some homework on it, and I've seen a lot of the trial videos on the internet, and I really just want to see how well it penetrates and all that. And then ultimately, I'm looking for what are the requirements for that room?
Oh, for the laser safe environment. So what you want to do is create what's known as a laser controlled environment, and that's going to vary depending on your situation. So if you have like 20 people in this room, you'll probably want to isolate the process into a laser controlled environment. If it's just a few people, it might be the best choice to have everybody wearing these glasses at all times. But ideally, the concept is you want to keep the light from being able to access the eyes of those who are not wearing this PPE. So the panels that we have here, they're made out of aluminum. They don't have to be aluminum. That's just what we make them out of. And we have overlaps on the outer skin. So this outer skin here is actually overlapping the next panel, which is bolted right here. See the bolt? Any windows are going to be laser safe windows. So this is an OD8 plus acrylic here. And that's the rating that describes what kind of filtration it gives for the infrared wavelength of light with the 1064 nanometers. A roof is not necessary for your room unless you have, say, a second floor with a window that may look down into this environment. And if that's the case, it may be easier to just put laser glass on that window. Um, or just block off the window altogether. Um, and you need an interlock switch on the door. So the entryway to the room will need some type of switch. It's kind of similar to an alarm switch. It's going to be in the case of the ones that we sell, a magnetic reed switch. So when the door breaks contact, basically it shuts the laser off. And the light weld is actually built in with those circuits already. So you'll just need to
Right, I guess what I'm looking
wire it
for
to
is
that.
what do you recommend for like the size of said room?
Oh, well, that just depends on the size of your weldment. If you're welding very small stuff, say the stuff that you're welding would fit right here, you know, as long as you have enough room to move around in there, that's good. I think the smallest one we've
Okay.
done is like 8 by 8 feet, or maybe it was 6 by 6 feet. Um, and we've done very large ones also, multi-cell rooms, 30 feet long, stuff like that.
I have a feeling ours would be on the smaller side, but I would want to make sure I'm working in conjunction with what Mike's vision is there.
Yeah, you'll just have to do an analysis of your process and kind of figure out, obviously you need size enough to fit the welders in there for whatever kind of welding table you need, or fixturing equipment you might need. Um, and uh, and yeah, you can go from there. But the rooms that we sell are divisible in 2 and 4 foot increments. So
Okay.
that's kind of something that would make it real easy to plan around. Is just typically the standard panel's 4 foot. We do have a 2 foot panel. The doors have 4 foot openings or 6 foot openings by default. Some custom stuff can be made, but typically that's kind of where you're at with what we offer for our booth systems.
Actually, that would be perfect.
Okay.
And
Cool.
then I'll ask a question real quick.
Yeah.
So because you're using laser, you're not really worried about any UV scatter because it's not an arc that you're using.
Yeah, so the UV light that's produced by this is only going to be from the glowing material or any contaminants that may be burning off. So the laser itself doesn't produce any UV light. It's just an infrared laser beam. So you're not going to get a sunburn from this process, although it still is recommended by the manufacturer to wear full coverage clothing since you are welding and you're working with hot materials. It's not so much for the sunburn risk, the skin cancer risk. It's more for working with hot materials.
Yeah, you'd only have secondary UV.
Yeah, yeah. So I mean, I almost never wear long sleeves, and you can see I'm pretty pale. I use this just about every day, a couple hours a day probably. Yeah, so yeah, really the main risk is the eyesight. So these glasses here, um, this is just one of the many different styles that's available. They're available in prescription also, but these are OD7 plus rated laser glasses. So that's 7 plus means that 1 photon out of every 10 million. 10 million has 7 zeros, right? So 7 plus. 1 photon out of every 10 million will be able to pass through these. So it's an extreme level of filtration in the case of a reflected infrared light. And at that moment, it would be scattered anyways, so it's a lot less likely even then. But yeah, pretty much anybody that's in the vicinity of this welding or that laser controlled environment will need to wear these glasses. So if I'm welding and there's a guy over there, even if he's facing the other direction, grinding a part, prepping it for weld, whatever, he's going to need the glasses. As long as this wall is separating everybody else, they don't have to wear the glasses. Yeah, and if you need some more information on like the booths and all that, Glenn can give you some more information about that. Or Ryan, whoever's your contact. Yeah, so with that, is there any other questions before I move on to talking about the welder, the settings, and then doing some welding?
I think I'm good
Yeah.
right now.
Okay. All right, so off to the left of the screen there, the one with the orange is the one I'm using. That's the XR, LightWELD 1500 XR. If you're going to do primarily aluminum, I would highly suggest purchasing the XR unit. It's a single mode laser beam, so it has a higher energy density than the multi-mode lasers, which is like the one you see next to it. You can always tell by the color of the machine. It's the multi-mode systems will be black and the single mode will be orange, or like an auburn color. And yeah, so the single mode fiber is it has a spot size of the laser beam about 3 times smaller than the multi-mode. So that increases the energy density by 6 times. And that increased energy density helps combat the reflectivity of aluminum to the infrared light. So infrared light sees aluminum and copper as another one as similar to the surface of a mirror. So it's very hard for the light to couple with the material. So the single mode beam makes that much easier at lower powers. You can weld aluminum with the multi-mode systems, but typically you have to crank the power way up, and it's a little bit less controlled. You got to move much faster to control the heat, and it's just much more of a headache than using the single mode. So I always recommend any aluminum work, just get the XR. So yeah, that's what I'm using here, the 1500 XR. All of the light welds have some type of chart here that lays out your settings. This is a photocopy, so excuse the fact that it's black and white. It normally is color coded and all that. It's a little bit faint, but you can see based on the material type and the type of weld you want to do, you'll select, for this instance, I think most of my aluminum here is 6000 series. So I choose aluminum 6000. It's telling me to run argon gas, which is what's recommended. At the moment, I am running nitrogen gas, so you won't be able to tell the difference on the demo, but the results will be improved if you use argon. It's more of a microscopic level type difference there. So it's recommending argon. If it's not a critical strength application, you can probably get away with using nitrogen. The welds seem plenty strong, but if it's very critical, I would recommend using what they recommend, which is argon. And it recommends you a wire alloy that can vary depending on what you need, but I am using the recommended alloy currently of 5356 wire. And it tells you a wire diameter that these settings are designed around. You can change that, but you may have to adjust the power slightly on the settings. And so my base setting is going to be F5. So I gotta go and change it. I have it set to F4 right now, and I'll show you how I do that. So F5. And let's start around 1000 watts. 1000 watts is kind of what's recommended for about 1/8 of an inch or 3 millimeters of penetration. So we'll just start with that. And it also recommends you a wire speed here. So this whole table here is designed around wire welding. There's some information about how to set up the wire feeder for different materials. And then there's different charts for if you intend to fuse the metals together without a wire. If you're doing tack welding or spot welding, there's a table for that. And then there's also a cleaning, there's cleaning modes here that dictate the, oh, here's one that's color so you can see. Probably read it a little easier. Cleaning, tack welding, fusion welding, wire welding, and the setup information. So typically I follow this chart to start with my settings. And if I need to make some changes, I'll make minor changes from there. If you do have a unique application or something that's not listed on the chart, you can make custom settings. You can do that either with the use of plugging in a laptop, or we also offer this tablet now as a new product. It's called we call it the Light Mote, like a remote for the LightWELD. And basically you will access this application. Maybe I should zoom in on this down here. You'll access this application and it allows you to take a little bit more control over the LightWELD for custom settings. So most of the time you're not going to need that, but it can be useful for tricky applications. But yeah, so another benefit of this is that, for instance, right now, the LightWELD, I can't reach from where I'm standing. I need to walk around the welding table. This is wireless, so even if you're at the end of your 30-foot cord, you can still control the welder from here. So I can choose any of the factory settings. For aluminum, it would be, F5. And then I can control the power, some different parameters. I could view errors and all that. If there's an error code or a trouble code, it'll tell you what that is and how to remedy it. So yeah, there's a lot of control you can do here. And when you get into making custom settings, you can take more control over every parameter. Sorry, it's telling me I'm disconnected because this is actually hooked up to a different welder on the other side of the room. But yeah, so you have a lot more control by using the user settings, but most of the time you don't need that. So for this demonstration today, I won't be using this, making any custom settings. I'll just use the factory ones. And then when you've made a custom setting, you can save it. and it'll save onto the machine. So you actually don't have to use this if you don't need the next time you go and make a setting.
Can that control all the welders that are in that room since you said it was hooked to a different one? Or does it only hook to one?
I'm sorry, you're very faint with your audio there. I don't know if you're,
He wanted to know
Matt,
if you could control more than one with this from the same tablet.
no, you can only control one with the same tablet, unfortunately.
And then
I
on the
don't think it'll
cleaning,
affect it anyway.
Yeah, if you had multiple, it would be confusing probably to control multiple because you may change, say you have two running at once, you might accidentally change your neighbor's settings. So it's best to keep them separated.
on the cleaning settings, is that for cleaning the workpiece, like going back over the weld, or what is that for?
Yeah, typically it's for weld prep. You can also clean after the weld. A lot of people do that with stainless steel to remove the oxides, the discoloration off the surface. You can do it with aluminum too. It'll shine up your welds but its intended purpose is to make a better, stronger joint, is to clean the material. It's not meant for like cleaning a bunch of rust off a part. It's only this wide of a path, about 15 millimeters. It's more for prepping the joint for the weld so that you have a cleaner weld. The laser itself doesn't care if the material is dirty. You'll be able to weld it if has the oxide on it, if you have slight amounts of oil on it, stuff like that. The laser will weld it. It's not going to be any more difficult or anything like that. It's just that if you have a critical application, you'll want to clean the oxides off first and make sure that your weld is nice and clean.
And keep those from getting pulled into your weld pool.
Yeah, so yeah, but see, most people don't worry about it because unless it's real critical, but say you're doing like a, food or scientific grade stainless weld, you'll want to clean it first. Aluminum, even with the oxide layer, the laser really will just go right through it and that everything on the surface will just end up on top of the weld. It's kind of interesting. When you see writing on like 6061 aluminum, it'll end up on top of the weld afterwards. But it may be better to clean it. You just kind of have to make that decision on your own. But yeah, so that's what it's for, more joint prep rather than, general material cleaning because you have to touch the surface and it's only this wide. Yeah, okay, so that's how you make the settings. So I have to manually change this one because it's not hooked up on this welder. So let me go ahead and show you how I do that. So I told you I was gonna set it to F5 with 1,000 watts of power. I will have to increase that at some point for the thicker material. But essentially you control the mode here. So if I wanted to change the first character, I would press and hold these buttons and they're just directional. So I'll go back to F. And then quick presses will control the second character. So F5, and then I'll just change the power here. So I can put it at 1,000 to start. Yeah, so that's for about an 1/8 inch. I think the material I have is a little bit thicker than 1/8 of an inch. So I'm just gonna bump it up to like 1100 and I may make an adjustment to that. I may not, depending on what I see. Power is just gonna control the penetration depth. These settings here represent a percentage change with the wobbling of the laser beam. So the laser beam is very small. It's about 2/1000 of an inch in diameter. So in order to create a sizable weld, the laser scans side to side and in a wobbling action. So that's already built into this setting, but you can do plus or minus 50% on the length, plus or minus 50%, and the frequency or how fast it's wobbling, plus or minus 50%. And so you can slightly increase the profile of your weld or decrease it and focus your energy. These settings will affect the penetration depth. And so you might have to also make a power change, a little bit of a balance because you're spreading energy around at different rates and different widths. But most of the time, the factory setting here for the F5 is going to be sufficient. So a lot of times will never change these. I do, however, make some adjustments to the width when I'm doing an outside corner weld to get a better radius on the weld. But I'm just going to leave it alone to show you how the factory settings work. So that's the base setting for aluminum, the 6061 aluminum that I'm using. And then this is the power that I've selected. And then my wire feeder is not in camera view. But it's a separate box essentially that, um, it's a separate box that houses the wire reel and has the drive roller. So you just set the speed and the wire will feed out at that speed. So I have it set to what the chart says, about 70 centimeters a minute. If you go slower, you're going to get more penetration. If you go faster, you're going to get less penetration. So you may have to adjust power for that as well. But if you set it exactly where the chart says, you should be getting the result that the chart says also. Okay. So any questions before I do some welding?
I'm ready
You want to
keep
go
going.
over the gun maybe?
Yeah. I'll go over the gun. Good point. Okay. Sorry, this controller is a little finicky. Okay. So this is the gun. See the size of it here in my hand, a little bit bigger than a MIG gun typically is. You'll have some cabling coming in from the bottom. This is your fiber optics cable, so you want to keep this from kinking and breaking. I haven't heard of many of them breaking, but it has happened. This is your gas line here, these green ones. So that's what carries your shield gas into the gun. And then there's electrical wires for the buttons and lights and such right here. This is trigger number 1. So you press it with these fingers. This is trigger number 2. This one feeds the filler wire. You can see the wire here feeding out when I press that. And I can also set it to retract a bit, so I can control my wire stick out at the beginning of the weld. You don't want to do it over too long of a distance, but it can be real helpful for small adjustments. So yeah, the way we'll weld is we will approach our surface at about 50-degree angle here, so handle level with your surface. Touch the surface with the correct stick out, pull this trigger. We'll get a flashing green light only when we touch, because it won't fire the laser unless we're making contact with our weldment. And then once it's flashing, you can pull the second trigger and it'll fire the laser and begin feeding the wire. So that's what starts your weld.
So are you contacting with the wire itself is what it's looking for, or the tip?
Well, the tip is touching the wire. So the
Okay.
electrical contact is going through this part of the gun. It's isolated from here, so you can't touch it anywhere. Just it has to be from here forward. And then, but the wire touches the tip and then touches the surface. So yeah, you're making contact with the wire. If you're
Okay.
fusion welding, you will be making contact with the gun directly. And then that introduces the first consumable item, which is these copper nozzles. They don't wear very fast at all, especially when you're wire feeding. You'll almost never wear one of these out because the wire is what's contacting the surface rather than the tip. But when you're fuse welding, that tip will be dragging directly on the surface, so it can wear out. That just unscrews. It's real easy. This is another style. And you can see it just unthreads. You can thread a new one on. They cost roughly $30 to $35. I make mine last for months. I can't even remember when I've changed one. Typically I change them more because I've dropped it and damaged those threads rather than actually, wearing it out. And then the next consumable item is it's a cover window for the focusing lens of the laser. So the focusing lens that takes the light and focuses it to a fine point here. Oh yeah, I'll show you on this other gun. I have a dummy welding gun that I could show you on. So yeah, there's this quarter turn bayonet lock here. That's that's the cover slide. So this is the protective window. It's just a small, oops. It's a small glass window that protects contaminants from going deeper into the gun. So this may be replaced from time to time. It's an as needed replacement item. It's not something that you'll do on like a service interval or anything. The more clean you are with your process, the less you'll have to replace these.
Was there
And then this
anything
is,
special you had to do to keep your tips clean? You said you hadn't changed them in quite a while.
the tips don't really get dirty because there's not very much spatter with this process. They'll get a little bit of buildup right where the wire meets the tip. And then I just typically with the nozzle in a downwards position, I just kind of brush it off with my fingertips and it falls off. Nothing really sticks
Okay.
to the copper. So it's real easy. You can just, take a brush and brush it off. But the idea is you want to try to just prevent contaminants from going in. So you'll notice that this mount puts the gun at a downwards angle, so dust can't fall in when it's just sitting here. It's also, the machine is also provided, or provided with the machine as a red, just rubber cap that comes on the machine. So it's advised to put that back on when you're not using it. We pretty much never put them on and we don't really have a problem dirtying these windows, but our environment's not super dirty where we are right now also. So if you have a real dirty shop, you want to take some extra measures, to keep dust and contaminants out of there. This little window here is about $13, so it's not extremely expensive to replace. And it's really easy to replace. You see I can practically do it with one hand.
Right.
If I needed to, but you do want to wear some rubber gloves when you're getting into here so you don't put fingerprints on there. And then the focusing lens is this. This one's missing the retainer spring, so it pops right out, but this is the focusing lens. This is what you really want to keep clean. Because any contaminants that go beyond this point or get on this lens will affect the performance of the laser. So if the light hits something on that lens, it's kind of like having a, dirt on your car's windshield. It's not going to get to your eyes as good, or this light's not going to get to the weldment as good. So that's the whole purpose of that other lens, is to keep this clean. And then when you change this out, if you, it's a replaceable item, it's not considered a consumable item. But if you do have to replace this, that's like maybe just under $200 for one of those lenses. And you want to be extra careful at that point. You want to maybe move the welder into a cleaner environment, than a workspace, maybe like an office, and just be real careful, because once you expose the innards of the gun to dust, then it's, you can't just go in there and clean that out easily. So, these are precision optics. We have to make sure that we're careful with this when we're changing those things out. But again, so long as you are reasonably clean with your process, it shouldn't be a problem as far as how often you replace those things. Okay, so I guess I'll get into doing some welding. If you guys have any questions, then don't hesitate to ask. Oh yeah, another thing, I did forget one thing. So I mentioned the glasses, very important. That's the most important safety feature. This helmet is also going to be provided with the system, one pair of glasses and one helmet. And the helmet's less to protect your eyes, more to protect the skin on your face in case of a bad reflection. It's not common, but it can happen. Basically, the plastic can melt, but this aluminum will be completely resilient to a scattered beam. So this helmet is designed to just protect the skin on your face in case of that event. And the glasses are doing the protecting of our eyes. There is a new helmet that's going to be offered here should be early next year. And it's a little bit more elegant than this one. This one has a little bit of weight to it with that aluminum shield on the front. It's probably the only complaint that I hear of with the LightWELD system is people really don't like the helmet too much. But that new one, I've used it and it's really good. So when that comes out, I would definitely recommend trying to get one of those. All right, and then what kind of configuration are you going to be doing with the aluminum welds? What kind of parts are you making?
Do a lot of the outside corner welding stuff.
Outside corner welds? Okay. All right, so I set my machine for 1/8 inch. This is roughly 1/8 inch here. So I'll go ahead and I'll tack this up and then I'll run a bead on an outside corner. I do recommend trying to do some type of an overlap on your weld. An open root weld joint is not typically what's best for laser. Laser welding likes nice tight fit up, so the better you can fit it up or overlap it, the better time you're gonna have welding it. So I like to do about a half overlap if I have the ability to. Also, you don't build up a whole lot of material when you're laser welding, so you know, doing the overlap also minimizes the filling you have to do on that. You know, you're not gonna have a massive bead. You're gonna have a really nice tight bead with deep root penetration. So, you know, it's not the greatest process for making a massive weld. And the idea is you don't need it because you have really good root penetration. Okay, so I'm gonna just go ahead and run this weld right here. You can see we have a pretty decent right angle there. Here we go. All right, that looks pretty beautiful. We got really good weld penetration, full penetration there. Let's zoom in so you can see that a little better. As you can tell, that's pretty fast welding. You know, it's got like the precision of the TIG with even more speed than a MIG and more strength than all of them. Can almost not see the weld, kind of blends in nice. And then here on the back side, you can see we have full penetration on there. And then I'll try to give you a little bit more zoomed out view so you can see the distortion that we're getting. In most instances, it's nearly nothing. All right, what do you think about that one?
Good looking weld. Aluminum, that's not easy. Traditional ways.
Yeah. I've been doing TIG welding for a while and I actually prefer welding aluminum. I think it's, in my opinion, it's easier, but I know that it, you know, when you're used to steel and stainless, it's a totally different thing.
Right, right.
But with laser, all the materials weld pretty much the same. You'll notice slight differences. You know, for instance, if you're welding like some titanium or aluminum, the weld pool seems a little bit more like fluid. And you don't have like as much of a feel in the gun as you do when you're welding steel and stainless, which has a super positive feedback. Uh, you know, there's totally different things to consider with laser. We're touching the surface, so you're not used to having a feedback. But with the laser, that wire that's feeding into the joint is actually pushing the gun backwards, so it sets your speed. If you want to go faster, you speed the wire up. If you want to go slower, you slow the wire down. So that feedback I'm talking about is kind of that push you're getting. You get a little less with aluminum, titanium, and then steel and stainless. You have like a really firm push, and it'll just force you along. Okay, so there's about 1/8 of an inch. Let's jump up to something a little thicker, some 3/16. This one I'm gonna weld in a different joint configuration because we're gonna have an even bigger valley to fill if we have more of a corner to corner. I'm gonna do like a butt joint, a corner butt joint, and I'll attempt to get full penetration, you know, through to the backside here, which I should be able to do. So what I would probably do in this situation is set it up like a butt joint. You know, this is all dependent on your strength requirements too. Maybe you don't need full penetration. I don't know. But I would probably do this and then I'd throw a slight chamfer on one of the edges to give just the smallest valley, and that valley will give you your wire an easy time staying on path. So if you have a complete butt joint, it's kind of like a flat surface and it's kind of hard to stay right on track because we're pulling. But if you have a little valley, that wire will follow along that valley, makes it real easy. Yeah, so let me go ahead and crank the power a little bit. Let's see what the settings say. The settings here recommend probably more closer to the maximum power, which is like, you know, 1500 watts. And that'll be like maybe 200 thousandths penetration. I'll just max it out. We'll see what happens. It's more than the material thickness, but you know, we'll just see how it works.
So going back to that first weld you showed us, Is there a way to fill that more than what it was? Could still see a gap there. And I guess the second part of the question would be, is there a reason you didn't do that?
Filling the gap more. Yeah, so as I was mentioning, the laser welds, they're just they're pretty small. You're not gonna get a big pile up of material. That's just not how it works. And if you wanted to
Would
build
there
up a
be
lot
a
of
way to fill
material,
that more?
Or you could use a butt joint on that too, right, Evan?
yeah, you could use a butt joint here, like I'm gonna do with this material. And that would work just as well also. But typically, if you
And
want a
maybe have
little
it
bit of a
go ahead
bigger
of it.
bead, you'll need to use a thicker wire, maybe like a 1/16 inch
Okay.
wire.
And you're using an 045 wire?
Yeah, I'm using 045 right now.
Okay.
And another option is if you can't get, if you need an even bigger wire, that the wire, see the wire feeder's maximum is 063. You can actually use a TIG rod, lay it in the joint, and then fuse over it, kind of act like you're doing the same thing as the wire feeder, basically feeding that wire from below. And then you could just fuse over it with the gun like that. And there's
Okay.
no difference as far as uh, like the quality of the weld. It does the same thing. It's just a little bit more, tedious to do it by hand. All right, so let's try this thicker material. Quick little tack through. All right, and yeah, so I'm just gonna go ahead and I'm gonna kind of try to fixture this a little bit so it doesn't flop around on me. Okay, so yeah, I'll just run this bead right here. Stop about halfway through, kind of see what we're getting here. So I can see that you might not be able to see, there's a tiny bit of full penetration right there. I think what I need to do is slow my wire speed down. That's one thing I forgot to do. Let me slow the wire speed down just a little bit so I can get more weld penetration there. Yeah, you could see there we're getting better weld penetration on the second half. Let me try one more now that I know that the settings were a little off. Start by tack welding it. Wish I got less penetration somehow. Maybe I maybe the part on the other one had a little bit more heat built up into it while I kind of looking at it. So let's try one more adjustment here. Narrow the beam just a little bit, try to get a little bit more of a focused energy. So once again, I'll tack weld these guys. Might as well make a box. Okay. All right, here we go. Yeah, I'm gonna look on the inside. Yeah, that one full penetration the whole way down. Let me see if I could zoom in. So I just narrowed the beam a little bit to focus the energy, and then I slowed it down about 5 centimeters per minute. You can see we get penetration the whole way down. And this is the top surface of the weld. It's this one. That's pretty good. That's, I think this is 3/16. It may be 1/4 inch, but I'd have to measure it. That's pretty good for decently thick aluminum.
Yeah.
And then, yeah, let's run these ones. I'll just go back to back. And that one, this part's pretty heat soaked, so that one definitely was a little bit hotter. But yeah, full penetration on the inside, so those will be very robust. And that one's smoking hot, so I'm not going to touch it. Typically, though, the welds with this are not nearly as, the part doesn't get nearly as hot as you'd see with a TIG or a MIG, simply because the energy is 200 times as energy dense as an arc weld. Like a MIG or a TIG, typically for a square millimeter, will have 50 watts of energy, and the laser has 10,000 watts of energy per square millimeter. So it gives a 200-fold energy density increase. Here's another thing that is typically, tricky with, MIG or TIG. So a thicker material with a thinner. So we'll go with this 3/16, and then I'll weld this piece of 16 gauge to it. I'm simply going to set my power for the 16 gauge. So look at the chart here. My power should be around 650 watts. So I'm just going to go to the machine, change that to 650. I'll put my wire speed back up to about 70 centimeters a minute. 650 on the power. And then, you know, with how hot is this piece? That's still pretty hot. I don't want to show you an example where it's been preheated. So let me try to grab a part that is cold still. Because you know, you don't typically have to preheat with the laser either. That the beam will just go right in there and do its work. Doesn't really need that preheat in most instances. If the material is very, very thick, like, you know, 2-inch thick aluminum, something like that, you know, a preheat might be helpful, but you know, standard stuff like this, it's not. So there's a cold piece of 6061. And let's go ahead and weld this guy on there. Gotta get you an angle that you can see there. Let me zoom in way in. Looks like my angle was a little bit off at the beginning, and we have definitely had some kind of contaminant because I had a little pop right here where that little divot is. But you can see thick to thin is no issue at all. Just kind of keep going and weld some more. I think I could use just a little bit more power, so let me just bump the power a little bit. And then you can also, I'm gonna show you here that you can actually build a little bit more material up. But you end up adding a lot more heat into the part because you're going slower and pausing and letting the weld build up. So at that point, you're kind of giving away some of the benefits of the laser, but let me just show you that you can do that. Kind of hard to do with one hand, so let's see. Yeah, I need to find a way to fixture this. Hold on. Maybe I'll do it like that. Yeah, a little bit more power for that thicker material is going to help me there. Sorry, I dropped it down for the thin stuff and then I went right back to welding some thicker stuff. See, because we have to make contact with the part, you saw it stop a couple times there. Because I was just kind of moving a little bit too abruptly. You got to be real smooth when you're doing this. But you can see I was able to add a little bit more material there than the other welds. And let's weld this last joint here. And let's see on this one here with the thicker material. Let's see the effect on the inside of the tube. Let me try to get you that angle there. Should see some type of movement to the material. Might need a little light. I think you can kind of see a little bit of. Yeah, it's too bright. Yeah, see that? A little bit of a shadow to the material there. So we are getting good penetration into there. All right, is there anything else that you'd like to see or any other kind of welding? Any questions?
Is there anything that we could get for like AWS specs on laser welding?
There is a few AWS how do I say it? There's been people who have I don't even know the terminology how to say that, but some aerospace companies have proven that it meets the AWS standards and they're using that in some aerospace stuff. As for others, I'm not entirely sure. Glenn and Ryan could probably provide you with a little bit more information. Myself, I don't know off the top of my head. But it is, keep in mind, this is a fairly new process, handheld laser welding. So, it's going to be evolving more in that regard. The laser welding process itself is pretty well proven and documented. And I'm sure it's met quite a bit of specifications in that sense. But as far as handheld goes, you'd have to look into it, or maybe Glenn or Ryan could provide you a little more info on that.
Yeah, well, I can provide you some more information on that.
Hey, were you able to weld any thin aluminum together there, Evan?
They said 90 thousandths and up is everything.
Oh, okay.
I did
Okay.
I did do some 16 gauge though.
Okay.
Can you show us any fusion weld samples?
Yeah, I can try. I have, yeah, I'll sometimes the fusion weld on 6061 is a little tricky. It does work, but if you don't ramp down the power just right, it can still crack. But let me try. I think everything I have here is 6061, so that's why I say that. 5052 and like 3000, 1000 series aluminum, you can fusion weld all day long, but 6000 you just have to be a little careful with. Yeah, let me try that. So I'm
that
gonna
would
put
be
on a
my
tip
next
that's not
question.
for wire feeding, and then I'll turn off the wire feeder. Let's go to Fusion 6000 series. So setting F4, 900 watts should be good. So let's go ahead and do that. I'm sorry, did I hear somebody saying something there?
I was going to say that was going to be one of my next questions. Isn't 6061 typically brittle when you weld it?
Yeah, it is. And that's why you have to get the ramp down of the power just right with this. So if you have a divot, it's more likely to crack. But the laser having such a focused energy, you're having with a smaller weld pool, right? The weld is smaller. You have less contracting to the metal. So it's less likely to split. And, they have settings right there for 6000 series fusion welding, and they've done a lot of testing. All these settings that are developed on this chart, they've done, countless tests, cut and etch, X-ray on every single one of them to develop these settings. So obviously it's able to do it. The single mode version, the multi-mode one, you can't really do that. But the single mode, the XR models, the energy density is focused enough that you can actually just fuse weld it. So this is 6061. We'll see what happens. I've had it succeed many times in the past, but I don't do it that often. So let's give it a try. Okay, so I'll start with tack welding.
Now, is that giving you a visible light guide right there that I'm seeing?
Yeah, there's a
Or-
red dot. That's a guide beam.
Okay.
So it just tells you where the laser is gonna hit, because the actual welding laser is not visible.
Yeah.
And I'm just gonna use for fusion welding on a butt joint. I'm gonna give myself a guide so I can make sure I stay nice and flat. That's what I do on butt joints typically. With wire welding, you don't have to if you kind of, set it up so where it'll guide you on its own. But for fusion welding, I don't want to be able to slide off to the side. So when I say you want to get the ramp down right, you might see at the end, I kind of pause and then the light slowly dim down. That's because I let go of the trigger. That introduces the ramp down process, and I want to let that finish before moving on. If I kind of let it fall off the edge, like I weld and I just kind of do that, you're not letting it properly cool. So the weld pool kind of solidifies abruptly and then will increase the chances of a crack. Kind of similar to TIG welding, you want to slowly back off that power and kind of move around a little bit to eliminate the chance of that, the crater there. That piece of aluminum I was holding was getting hot, so I'm going to switch over to this different piece of metal here. All right, so there's a beautiful fusion weld joint on the 6061. I guess we can try to do a destructive test just for fun, see if it will crack on us if we try to, smack it pretty hard. I doubt it. It looks like it worked really well. These are always fun to do.
Before that, would you mind zooming in to the corners where you picked up and finished your welds
Yeah.
so we can see those?
So these are a little bit undercut on the corners just because I was, we're borrowing that material there, and that's kind of where the heat builds up. So you will see there's little kind of like cut out almost. If I wanted to eliminate that, I'd probably start my ramp down a little bit earlier. So let's just kind of try that here. I'll start it here and then kind of keep moving. I just did it in a different way. I'll stop my ramp down about a centimeter early. I didn't do very good.
Hey, could you show them how you can fill that with a TIG rod?
Yeah. Anyways, I didn't get it just right. It would take a little practice, but you can probably see that this one I just kept, this one here, I just kept moving as it was ramping down. You can kind of see it taper out there. And so there's not really a crater. There's a slight undercut because it is a fuse, but there's no crater. And same here. These aren't craters. They're just kind of undercut because that's where the power ramped down. Try to show you a little better view. And then if I wanted to fill that in, like Glenn was mentioning with the TIG rod, that's something that you can do pretty easily also. So if you were fuse welding and you didn't want that to happen, you could just have a piece of TIG welding rod handy. And then you could I didn't get the angle very good there. Anyways, you can kind of just feed some TIG rod right in there and build up some more material. Sorry, my lighting's not that good, so I'm having a little trouble seeing. But yeah, that's another way to do it. Also, that can work. Let's say you have like some holes that you want to fill something like this. You can pretty easily accomplish that with the TIG rod also. All right, try to break this. So if this is cracked because of being 6061, I would expect this to break here. And I haven't really looked too close at it, but I think we were pretty successful with that. Yeah, I think we got it pretty good. We're pretty well bending this down here.
Hold up well.
All right. Any other questions? Anything you want to see?
Covered a lot of bases for me.
If you did have any other questions, you can feel free to reach out and we can try to answer that, or maybe do a quick video snippet just showing that specific application as well.
Maybe just show them the robot in the background there.
Yeah, sure. Yeah, so we've also integrated this LightWELD system with the FanX CRX series of collaborative robots. This being the CRX 25 here. I'm not sure if it'll be happy with me moving it around right now because I don't have the gun in there, so the weight might be a little bit off. But I'll try to show you that, you can move it around real easy. Yeah, it seems like the weight's a little bit off. Just feels a little too light. But anyways, yeah, so using these two buttons on the front here. Yeah, see, it thinks it has the weight's way off, so it's like trying to float on me. Anyways, using these two buttons, you can adjust how it'll move. So I press the green button and now it moves, maintaining torch angle. I'll press it again, it'll rotate about the tool center point, which is where the gun's nozzle would be. Press it again. It'll go into a custom one, and then this is back to free mode. And then I can press this top button here and it'll collect one of those data points and input it into our program for our robotic weld. So kind of hard to show you that, but anyways, I could move it, press this, it'll collect a point, move it over here, press this, it'll collect a point. And then if I press and hold this for 3 seconds, we're working on that right now. That's actually not part of the software, so I shouldn't say that, but that's gonna initiate a laser on command. So we can, collect the point and then press and hold again, and it'll start the laser on at that point.
Could you show them like the icons on the tablet?
Yeah. Push this out of the way so I don't hit my head on it.
Uh.
And it's a big robot. It's 25 kilogram payload. It's really tall. It has a 7-foot or 72-inch reach, 6-foot reach. But it's very easy to move around. It's not like, it looks like it would be hard to move around. It's really not. Okay, so let me move down here to where I can show you the tablet. Yeah, so you can control everything through this tablet. You see the weld program here is going to have icons. So you'll basically select what commands you want to do. Maybe I'll zoom in a little more here. So you can do linear motion, circular motion. So you can like limit the type of commands based on what the purpose is. And then once you've been using them, you'll find that the history is going to be where you're going to be going most of the time. And you'll just, the ones you're using most commonly will come up here. And you basically can just click and drag an icon or a command into the timeline somewhere. And then it'll just input that command there. So you have your storyline of your weld program. You can input notes. I can put a little note here saying this is where the weld starts. So now if I want to edit it, I know I just go to, this position, touch that position up or change the coordinates. I can set the speeds, everything all from right here. So it makes it really intuitive to use.
Can you show them the Lightbot icons?
Yeah, sure. And you can also program, put in all your welding torch and your part and everything in this robo guide world so you can more easily visualize. And then, yeah, we have our own icons also that control the light weld. These are the Lightbot icons. We have laser on, laser off, adjustable cleaning modes, memorizable, welding settings, power settings, all that. So you can kind of preset all your conditions in this area and then just drag and drop. So you have an 1/8 inch joint or 1/8 inch material thickness for a certain joint, and then another joint has a thinner material. You can drag like weld preset 1, weld preset 2, and then so this just makes it real easy. The laser on and laser off have all the trigger sequences necessary for controlling the light weld. And so yeah, it's real well thought out. It works really well. And yeah, and it's just always improving. We're always developing more on this, and we'll have updates continually, but it's already pretty well dialed in. We've got how many of these are in the field right now, Glenn?
There's 20.
20.
Yeah,
okay, in the
we
field.
started selling them in June of this year. And that's completely retrofittable. You don't need to get that up front. You can add it any time.
Yeah, you can use it with any light weld system, and all it requires is a light weld software update in order to be able to talk to the robot. So if you did have a light weld and want to do a robot, you could just reach out to us and we could help you update the light weld in order to do that. Cool. Well, if you have any other questions, go ahead and ask, or if not, I guess we can stop the meeting. And then if you had any questions later on, you could reach out and we'll do our best to help you.
Yeah, we'll send
Yeah,
you
no,
we'll
from
send
my
you the
end.
video, and Evan, we could probably send them those parts as well, right?
Yeah.
I've actually done a little bit of the demo of one of these at the Fab Tech show, and yeah, I was pretty impressed with the way the robot was moving with it. So I'm very happy with all that. Your welds look good. I'm sure we'll have some other questions as we go. The AWS will be something that we're certainly looking for. And then, yeah, I think most of the other questions we had, you pretty well answered.
Cool. I'm glad I was able to do that for you. So yeah, just reach out if you got any more questions, and you could ask for me if Ryan can't answer, and that. So my name's Evan again. Yeah, thank you.
Thank you, gentlemen.
Thank you.
All right, thanks,
All right,
guys.
have a good one. Happy Thanksgiving.